Hey, everybody. I'm going to begin today with a compilation of your geologic maps, and then we're going to talk about the second part of Gusev crater. So, on this slide, I've put together the geologic maps that I was able to kind of get out of what was turned in um, and put them together. So they're pretty interesting to look at as a group, and this is something that I was hoping we could do in class and discuss together. But we'll do it here, and I'll put them up for you to share. They're not in any particular order. They're just the way that they are. In the bottom right-hand corner is a little clip of the 2014 Mars Planetary, the global map. And that's actually the most recent map. They take a long time to put together. They usually only come out, it's more than a decade of work usually. So it's really interesting to compare yours to each other and also to the planetary map. And one thing that I noticed as I was looking through these is especially the big craters, like how people decided to assign which ages to which craters. So there are a couple of different schemes going on. And it's also sort of interesting to compare how the ages were assigned in here and then compare when you look at here, they are 1, 2, and 3, how that compares to the planetary map. So if we look just for a second at the original image that you started working with and compare it to the planetary map, you can see that they broke it out into 4 different units. And this is because they were working on a much, much bigger scale. They couldn't look at individual craters the way that you guys were. They were sort of looking at big areas and sort of making these broad brush impressions. So all of this being sort of lumped together is relatively similar. These two being part of another unit that was considered relatively similar. And then sort of lumping in these big masses of material on either side. So you're always going to see differences in maps when they're looking at big areas compared to small areas where you can do a lot more detail in small areas. Just to put our focus area, which is inside this orange box, in some context, here's the rest of that region from the Mars global map. So you can see this gray unit is pretty extensive and it's pretty heavily cratered. The yellow unit seems to be much younger and kind of overlapping other things. The tan unit usually doesn't seem to be very heavily cratered at all. It's kind of it looks like a smoother unit. And then this reddish unit, we only see a little bit in our map area, but it's kind of moderately cratered and not quite as smooth or as young. And it looks like it's underneath the yellow. So that's sort of how those determinations were made. When they went to give interpretations to these units, I organized them here from youngest down to oldest, and I clipped these directly from the map. You can see that 3 of these units were assigned to the Noachian period because of their crater density. And then the yellow unit is a younger Amazonian and or Hesperian impact unit. So it's looking at just the crater and the ejecta. But one thing, and this should give you guys a little bit of a sense of how much lumping had to go on to make these maps, is that when you look over here, you can see that this early unit, degraded crustal rocks uplifted by basin forming impacts. You can see the middle ones, it could be volcanic, it could be fluvial, it could be moderately to heavily degraded. And again, this one is a mixture of impact, volcanic, and fluvial and basin material. So they weren't looking at things with necessarily the same eye, and it doesn't necessarily make their map right, and it doesn't necessarily make your maps right. They're all thinking about things from a slightly, they were thinking about things from a slightly different perspective. And so the big lesson here is that maps are an interpretation. And they are made on the best available data that you have. And sometimes that's fairly limited and you have to work with a small amount of data, and sometimes you have more and more resources. So one of the interesting things is that what you will see in the geologic community over time is maps getting updated. And if we go back to the story about Gusev crater, here's the map that I showed you of Gusev crater, and this is what had been published when they were trying to decide about rover landing sites. And this is the map that people were looking at. And we're thinking that especially this light sort of green colored unit in here was probably some sort of delta, and here was the river that was coming in, and that this whole crater area had been filled at one time. So they decided that this was an area of, sort of prime research interest because of the possibility of finding evidence for life, and sent the rover Spirit there. And so it was a really big lesson. Here is an example of one of the rover images that was returned from Gusev crater. And you can see from the size of the rocks on there and the fact that they're very angular that this doesn't exactly look like a quiet lake bed the way that you would think. In fact, it turned out that what they had thought were layered sediments in Gusev crater actually turned out to be mostly layered basalts, and that the whole crater floor seemed to be covered in flood basalt and impact debris that had landed on top of that. So this wasn't, it was just a completely different, it turned out to be a completely different way of sort of framing out these original observations. And the observations were that you seem to have layered materials that had a flat top and a relatively smooth surface. And because they were looking for, hoping to find water, they were thinking about it in terms of it being a beautiful delta. But in fact, what they actually found were these basaltic lava flow plains that sort of came up. This is the rim of the crater, some of the hills near one of the edges. And you can see that the basalt, it looks like it sort of filled in up to the edge, and most of the crater was flooded that way. So of course, what that leads to is a brand new map. And here on the left, you see, I think this is a 2016 publication from some German scientists. And they've assigned, there's some familiar features. Here's the larger part of Gusev crater here, which is the same as this outline in the older map. And you can see that some of the craters, the outlines match up, the smaller ones match up really well, like number 3 here and this one. But you can see that the way that they've grouped and assigned the units has changed because now they have more information so they can make a better interpretation. I think that's a really powerful example. And I don't think anybody was necessarily upset about it. It was a surprise for sure. People were really hoping to see something different or expecting to see something different, but you can't change what actually is. And so you can change your interpretation and sort of reframe your context that way.